And it's similar to number 2, where you're just going to fill in this table, and deliberately we left both sides open just so we know which is which. So if you're given x, we can find f of x. Can you guys see this good? Make this bigger.
Yeah, we can see it.
All right. And then if you're given f of x, then that should allow us to figure out what x is. Okay, so just simple in terms of our functional values. If I want you to find f of 3, then you're going to let your x become a 3. So that's 4. Square root of 4, we know, is going to be a 2. If I want f of 0, that just means you're going to plug in 0 for x. So now we're going to get 0 plus a 1. The square root of 1 is 1. So that's going to become a 1. If I now ask you for f of negative 10, so now watch how this will play out. This will be a negative 10 plus a 1, which is a root negative 9. So that's now what we just quizzed on. So the way we would write that, the square root of 9 is 3, and then the fact that we have a negative 1 underneath there, that's 3i. So we can plot that, or we can at least put that in for that functional value. We can go ahead and fill in our table, so go ahead and put that, but then we'll talk about what that means in terms of graphing it. All right, f of 2 would be 2 plus a 1, which is a root 3. That is not a nice number. So let's put in a root 3 for right now, and then we're going to have to talk about how we can graph that here in a minute. And then the last one now, notice what I've done. You have f of x. So I'm going to do that over here because this one's going to be a little bit different. So what we said yesterday is that if this is now f of x, what that means is the 6 is going to get plugged in here in our equation. So that's where you now plug in your 6. And then you're going to have a little equation to solve here. We've been kind of doing the opposite. I've been giving you squares, and you've had to use square roots to get rid of the squares. So now this is the opposite. Actually, you would have done these a little bit last year. In order to get rid of a square root, we use a square. So you have to square both sides. The square cancels out that square root, so we just end up with an x plus a 1. And then the 6 squared is a 36. Subtract 1 from both sides, and we should end up getting a value of 35. So x is going to be a 35. What I want you to do real quick, try to graph these points while I pull up the calculator, because as you know, it takes forever for this thing to load. So you have those points, graph the ones that you can graph and see what we come up with. And then I want to show 1 or 2 things on the calculator for those values. All right, come on, here you go. Okay, so 3, 2 is easy. That shouldn't be an issue. So 3, 2 would be right here. 0, 1 is easy, although I did it wrong, so maybe not so easy. Real quick, so 0, 1 is here. When we now try to graph this point, the whole idea of an imaginary unit, we can't graph an imaginary unit on the xy plane. It doesn't technically exist, okay? Only in our fake imaginary mathematical world do we have this value. So 3i cannot be graphed. Root 3 we can graph, but we just don't necessarily know what root 3 is. So this is one for the sake of graphing that we probably do want to go to our calculator and plug it in. And then graph this decimal. So that should be 1.7-ish. So if you go back to your graph this as if it's 1.7. So go to 2, and then go up right about here. And then 35.6, you're going to have a hard time doing that because 35 is going to be way off of this graph. So now what you want to understand is when we go ahead and graph this, so 2 and then 1.7 should look like, and then 6. So here's kind of what this now looks like off to the right. I'm going to show this on the calculator here in a minute. But then the question is, because a lot of time with our lines, when you would have graphed lines in the past, does this thing now kind of extend in this direction? Right, that's kind of what we want to know. So our issue with this now is, can we take the square root of negative numbers and get some values? So fill in your table. Give me a 0 right here. Let's do another number. Just let, oh, we already did it. Plug in a negative 1 then. So if we're at 0, plug in a negative 1. I'm sorry, negative 2. Yeah, negative 1. What am I talking about? Sorry, plug in negative 1. And then plug the negative 1 in up here. If x is a negative 1, we would get f of negative 1 equals the square root of a negative 1 plus a 1. That's going to give us a 0. So plot that point. And we know it looks like this. But now think if I go any further to the left of this. So if I now go negative 2 or negative 3, if I now plug in a negative 2 into this, wouldn't I be taking the square root of a negative 1? That gives us an imaginary. We can't graph an imaginary number. If I plug in, so this would be a negative or an imaginary. If I throw a negative 3 in here, now that's going to give me a root negative 2. That doesn't exist in our coordinate plane. So this graph doesn't go beyond that point. So you're going to simply start right here, and then we just go off to the right like this. That's what a square root graph is always going to look like. Okay, I can show you that on the calculator because the calculator never lies. So if we go ahead and do the square root of x plus a 1, and then we graph it, notice how it doesn't go any further to the left because these would all be imaginary. If I go to the table, right, if I start plugging in these negative numbers, see how it's giving me this error? Because those are all going to be imaginary. Okay, so that's what our graph would simply look like. All right, it's kind of a half of a parabola going to the right. Okay, next thing. Make sure we can do these. Understand these are nothing more than points. So when we write these in function notation, it's just a different way of writing a point. So go ahead and put x comma y right here. And then just understand when we did these, whatever was in here, this is your x coordinate. Whatever's inside of that parentheses with your function value, that's your x coordinate. So if I'm going to write this as a point, my x coordinate is a negative 1. And then when we plug the negative 1, the value that it spits out is a positive 1. That means that is your y coordinate. So that's just a different way of expressing a point. So negative 1, 1, we plot that. That's our first point. So this next one, it's as simple as saying x is 2. And when x is 2, we get a y value of 7. And then we can plot that. And then we're all bright kids, I think. This is 1, negative 1. We can plot that one. And then this last one is just 3, comma 0. And we can plot that one. So it's a little more specific, but it's really just a point when we write those. Okay. All right, so easy stuff, hopefully. Next one. When you do this, just like we did before, we do this in Math 1. Just a matter of now remembering. You're going to answer these questions now with a graph. So if we understand what we just talked about, then if I go to letter A, and I want you to find, this doesn't show up good for you guys at all, f of negative 4, then think about this as a point. Isn't my x coordinate the negative 4? And all this is now really asking me is what's this y coordinate when x is a negative 4? That's what we have to put right here. So you're going to go to your graph. You're going to find when the x value is a negative 4. So here's our x-axis. So we go on the x-axis to a negative 4. So that's going to be right here. And when x is a negative 4, what y value does our curve have? So we go up to our curve. And on the curve, when x is a -4, when we all agree that this y value here is a +2. So that's our functional value when x is a -4. Right? Same thing with this next one. If we understand function notation, like we just said on that previous page, this is our x value. So x is a 0, and this is now asking us what's our y value when x is a 0. So again, we go to our x-axis. So here's our x-axis. We go to where the x coordinate is a 0, so that's right here. And it just so happens that our graph crosses that point. So wouldn't our y value at that point also have to be a 0? All right. So real quick, see if we're understanding that. Do C and D. Make sure we have that down, because then E and F are a little bit different, similar but different. Although I suppose the next one I made a little trickier, because you're going to have to estimate a little bit. That's okay. All right. What'd you do, Cam, for f of 3? What do you got?
3,4.
Not quite. So let's see here. We want x to be 3, right?
Yeah.
So let's go to our x-axis. Here's where x is 0. Here, 1, 2, 3. So here's where we want to be. We want to find our graph here. And this is what I'm saying. We probably need to estimate a little bit. So everybody may have just a little bit different answer. But what's that close to, Cam? What do you think?
-2.
Yeah. I probably wouldn't want you to write -2 though, because does it go through the -2 nicely? No. So I would say anything smaller than a -2. I'm going to go like -1 point. Okay, perfect. Anything within that ballpark, I would be okay with. So -1. I was probably going to say -1.7. Me. He says -1 3/4. All right, that would be fine. We do have to estimate a little bit. Now we go to the -5. We do have a nice value. So if we come around here, go through all these values. So 3, 2, 1, 0, -1, -2, -3, -4. Here's -5. And at -5, notice how our graph is hitting right there. So the y coordinate there has to be a 0. Okay, go to that. E is now the opposite. Now we want to figure out, let's write this point underneath it. So what this is now saying, if we understand function notation, now I'm giving you the y coordinate is 2. And you now need to figure out what's the x coordinate when the y coordinate is a 2. So we want to go up to our graph. I actually have 2 already written, right? So here's 2. So let me do it this way. Let me highlight. So here's the x value of 2. Does our graph cross this x value of 2 at any particular x coordinate? Yeah. Do we agree it crosses that value 2 times? Yeah. So we're actually going to be writing 2 different answers here. So one of them is the point that I already have marked. So this guy right here has a y value of a 2, and that happens at a -4. So that's one of them. So we would say x equals a -4. But we also get another one, because doesn't our curve also hit the y value of 2 right around here? That's not a specific nice integer value. So again, you're going to estimate a little bit with a decimal. So I'm going to say it's just inside of a -1. So I'm going to go with a -0.8. As long as you're close to that 0.8, then you're good. All right. All right. F, last one. Figure out where the y coordinate is 0. So I'll do this one in green. Here is where our y values are 0. Look to see, does our graph ever cross that green line where the y values are 0? And if it does, what x coordinates does it do it at? And there should again be 2 of them. And both of them we've kind of already got, right? We talked about them. I already have this one marked. Here's where it crosses that y value of 0. That's the green line. It's where our y value is 0. So hopefully we got that -5. And then we also cross the y value of 0, the green line, when x is a regular 0. Okay? Pretty important stuff. That's something long-term, looking at a graph, understanding what our function value is at what x coordinate. That's something that you are going to use quite a bit. Okay? All right, this old idea now. See if you remember how to do this. Find an equation of a linear function. So old equation of line. Given that h of 1 is 6, h of 4 is a -3. So recall, we have done this. What you're going to write at same as writing the equation of a line given 2 points, correct? Because aren't these a different way of writing a point? So if I do this first one, let's first write this as a point. That's really just the point 1, 6. If we go to the second one, h of 4 is a -3. That's really just the point 4, -3. Last year, when you did this, you would have always thought to write the equation of a line, we need to know our slope. So our slope, does this hopefully look familiar to us? We actually did this a little bit at the very beginning of the year for a few days. That x sub 2 looks really bad. Let me erase that. All right, remember the slope formula? It should look familiar to you. You actually do that in 8th grade as well. That's how we can find the slope between two different points. So when we go to do this now, what these are just saying is I want the y coordinate in my second point. So this is the y coordinate in the second point. So you're going to plug in a -3. Then we're going to do minus. The next one means I want the y coordinate in point number 1. So here's the y coordinate in that first point. That is a 6. Then we go to the denominator. Similar now, we want the x coordinate. Let me do this in yellow. The x coordinate in our second point. So that's the 4. Minus the x coordinate in our first point. That's what this means. The x coordinate in point number 1, that's going to be that 1. So it should get -9 on top, 3 on the bottom. We know that our slope is -3. Then it's up to you. There's different ways now that we can do this. So once we have this slope, and then you can pick your best option, whatever you prefer. And you probably were shown both of these ways last year and in past years. Doesn't matter to me. So my personal favorite is point slope form. So do you remember point slope form? Looking like this. We also had slope intercept form, which is y equals mx plus b. Right. Those hopefully look somewhat familiar to you. We haven't had to deal with them very much at all this year, but you would have done a whole module on them last year. So if I choose option number 1, what we now need to do, we know what our slope is, right? So let's start with that. So the m is always our slope. We know that is a -3. So let's start with that. That's the easy part. What we're then going to do, let me create some non-highlighted things here. We then need to pick a point. So we can pick either one of these 2 points. So we can either pick the point, oops, I just erased it, 1, 6, or we can pick the point 4, -3. So Ella, what do you want to pick, Ella? 1, 6 or 4, -3?
Pick any one.
Either one of them will work.
4.
All right, so she wants to pick this point. So now all that means is I'm going to take y and I'm going to subtract. Notice how you have this little y sub 1 here? Oh, that was the eraser. So that means I want the y coordinate in the point that we just picked. So notice how that y coordinate is a -3. So I'm going to plug in a -3 right there. Then you're going to have x minus, notice where you now see x sub 1. Now go to that exact same point that Ella picked. The x coordinate there is going to be a 4. So we're going to plug in a 4 right there. So our final answer, if we leave it in what we call point slope form, is this. Okay, so that's one option. If we do slope intercept form, again, we know what our slope is. Our slope is the -3 that we got from our work here. So we're going to throw in a -3. And then we do the same substitution. I'm going to use the same point here that I have highlighted in yellow. The y coordinate in that point is a -3. The x coordinate in that point is a 4. And then that allows us to figure out what our b is, because that's what we need for slope intercept form. So -3 times 4 is a -12. To solve this, we're going to add the 12 over. So these will cancel. So the b is a 9. So what that now allows us to do is to write this in slope intercept form. So now you're going to say y equals the slope of the -3. And then we now know that our y-intercept is 9. So that is the answer if we do it this way. Do those look alike right now? No, look different, correct? And that's okay. But then at some point, and usually when we do this in your Math 1 classes, you would be told to now simplify this one. This is fine though. Like if you leave this as your answer, this is totally fine. It will not be marked wrong. But watch what happens if we simplify this. If I distribute the -3, -3 times a -4 is a +12. If I now subtract 3 over, won't this now give us y equals a -3x plus 9? Don't those now look the same? Yeah, so just different ways of writing it, okay? And you can pick whichever one you prefer. Okay, I actually like this one. I feel like this one's less work. Just get your point, get your slope, plug them in, and you're going to be done. But this isn't that hard either, okay? All right, next one. Given a little setup, it says swine flu is attacking Porkopolis. Easy for me to say. The function below determines how many people have swine flu when t is equal to time in days, and then the s is the number of people in thousands. So t is our time, and then the function s represents the number of people, okay, measured in thousands. Here is our function. So what this is telling us, the number of people with swine flu at any time is equal to 9 times the number of days minus 4. So for letter A, do that. This is what we did yesterday. If this is your function, you're just going to evaluate this when our time is a 4. So do that real quick. That's hopefully something we can do. Once you have that, write down what that number actually means. So we didn't explain anything yesterday, but find S of 4 and then tell me what that actually means. All right. In terms of the value, here's our function. So we're just going to take 4, we're going to plug that in. So we would do 9 times 4, and then minus 4. Simplify that. 9 times 4 is 36. 36 minus 4 should have given us 32. So in terms of the numerical value, 32, we did a bunch of those yesterday. Hopefully that's not a big ask. Letter B now is asking you, what does this actually mean? So the way we want to write this, we want to include both the 4 and the 32 in our answer. So what we're going to put is, here, Cross that out. On the 4th, and then understand what the 4 stood for, our time is days. So on the 4th day, comma, 32, and then understand what our function stands for. It's the number of people. So actually we're going to put 32,000 people. How appropriate is this question these days? 32,000, hold on, let me add another 0. Have swine flu. All right. What, Ahmed? It's appropriate these days, right?
I guess it does.
Yeah.
So,
All right. The next one's just the opposite. Again, we did it yesterday. Here's your function. I'm now telling you that S of t is 23. So now 23,000 people have it. So you're going to plug in that for 23. So let's take this function. So S of t equals 9t minus a 4. We're going to get rid of S of t because we know what S of t is equivalent to. You were told that it is 23, and then we solve that little equation. So add your 4 over, so we should get 27 on the left. Divide by 9. 27 divided by 9 is 3. What does S of t stands for? That just is telling us that now, on the 3rd day, 23,000 people have swine flu. All right. And then the last part of this, see if you remember this. If I wanted you to graph this, this is where you hopefully definitely remember slope-intercept form, where our y-intercept would be the -4. So you would go to your graph, go down to the -4 here. That's where we know we cross the x-axis or the y-axis. And then our slope is the number in front of the t here. That's 9 over 1. So from this point, you go up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then right 1. And then we can now graph that equation. Okay. All right, real quick. Let's make sure we remember how to do these from a graph. So if I give you an equation, we just did it. This you definitely want to do slope-intercept form. When you're given a graph, slope-intercept form, you should have done these endlessly over the last couple of years. I think this we're going to be pretty good at, I would hope. If we look at our line, our y-intercept is 0. So when we go to write this, we're going to be just doing a +0, which means you don't necessarily have to put that if you don't want. And then we have to count our slope. So pick good points. Let me make this bigger for people in here to see good. There we go. So here's a good point where I know I cross that corner. I'm going up 1, 2, 3, and right 1. So my slope is 3 over 1. So simplified, that equation is just y equals 3x. Okay. If you go to the next one, same thing. Let's figure out what our y-intercept is. We look at our graph. Our y-intercept is a 1. So let me get rid of this. Replace it with a +1. Find good points where we're crossing corners nicely. So I see one that's way down here. There's not a lot of them. Make sure you're going through the corners where we can identify what that exact x-coordinate is. So we really only have these 3. And then typically what I do when I introduce this, so those who had me last year, sorry to do this again, but we go 1, 2, 3, and we talk about how you could start at any point you want and go to any point you want, and it should give us the same slope. There is no order for this. All right, so Rebecca, what point do you want to start at?
5, 2.
All right, so she's going to start here, And then we're gonna go to here. So to go from 3 to 2, I'm gonna go up 1, 2, 3. So my slope is up 3, so that's a positive 3. And then from that point, I'm gonna go left 1, 2, 3, 4, 5. So I'm gonna go left 5, and then recall left is a negative move. So we get 3 over a negative 5. That now allows us to come up to our M. Oh, everything moved. And we now know our slope is a negative 3/5, and then plus 1. Okay, remember all this, hopefully. Okay, one more. Hopefully we can get done here. Here's our y-intercept. So when we go to do this, we know we're going to do y equals mx minus a 4. Y-intercept's the negative 4. We need our slope. So find some good points. Here's a good point. If I'm going to go from this point to this point, we're going up 1, 2. So up is a positive 2, and then I've got to go left 1, 2, 3. So that's a negative 3. We go to our slope then, and we know our slope must be a negative 2/3. All right, remembering all this, hopefully. Oh, actually, one more, sorry. So, quick refresher. Y-intercept is 4, so let's go ahead and change this to a 4. But then we have a horizontal line. So let me label some of these, and let's count our slope off here. To get from point 1 to point 2 to point 3 to point 4, think about how far up and down we have to go. So to get from point 1 to point 2, don't we have to go up 0? We don't have to go up or down at all. And then we're going to go right 1. So the slope of this is a 0. Think about what that means. If I let my slope equal a 0, isn't anything times 0, 0? Meaning this really just goes away, and our equation is y equals 4. So whenever we get a horizontal line, and this is what people screw up all the time, you only get the y coordinate. If I ever ask you for a vertical line, you're going to get an x coordinate. All right, but forget about that. Okay, good enough. We have enough of that done. You have that homework. All right, be aware of that. Try to get that done. It should just be nothing more than what we did here. So that should go pretty quickly. All right. Okay, we'll see you guys. Have a good night.
Wait, what's the homework?
So yeah, it's on Canvas. I don't have a hard copy of it.